Welcome to Architect Tips. I'm Jeffrey Palermo, and I'm going to show you today how to use architecture diagrams in a really easy way. Now, as we go through, there's a lot of resources, a lot of interesting topics on the Azure DevOps podcast. You'll want to make sure to check out that as a resource to you. And on this show, Architect Tips, I will answer your architect questions. All you have to do is tweet me at jeffreypalermo.com, and I'll pick a question, and if I can put it into a short 5-minute bite-sized chunk, then I'm just going to make one of these out of it. Otherwise, I'll just send you an email and I'll answer it for you. So go ahead and send me a question there. And so now let's get into architecture diagrams. And I want to make it really easy and show you some diagrams that I use. So let's take a system. You want to communicate what you want to either be built or what you're going to build with your teammates. You need to draw something. If it can't be drawn, it can't be built. Every profession that creates something has some type of design diagram. And so we need that here. So let's pretend that we are starting a work order application. We're going to build a work order application. And so we need some diagrams that are going to communicate it. And bread and butter diagrams is going to be your OO diagram. You could also think of it as a class diagram. Also, we're going to make ample use of sequence diagrams. Okay. Then you might have some patterns. In the case of a work order has a status and it has a workflow. And so we definitely need to make use of a state machine diagram. And a lot of times an activity diagram will be interesting, or a overall dependency diagram. So let's just take these and let's go through one at a time and see how quickly we can use these particular diagrams to describe a work order application in a fashion where you would actually understand what .NET code needs to flow from this. So let's start with a dependency diagram. I'm a fan of Onion architecture. If I'm laying out a Visual Studio solution and I say, you know what, it's going to be .NET, it's going to be Blazor WebAssembly, we're going to use C#9, and we're going to use SQL Server, we're going to deploy to Azure. Well, one of the first things is, what does my Visual Studio solution look like? So I'm just going to quickly spec it out. I'm not going to explain why, but I'm going to have a core library that's .NET Standard 2. I'm not going to go on all the rest of it. Then we're going to have a UI project. We're going to have a data access project, and I'm not going to worry about my handwriting. I'm just going to do this. And then we're going to have, let's see, what else? You know what? I know that I need some unit tests. So we're going to have a unit test library, and I'm going to have some integration tests. And these are going to be projects. And so, I need to have them here. And unit tests are going to be linked to core. Integration tests going to be linked to data access and core most of the time. And if I put in acceptance tests over here, most of the time they're linked to data access, core, and UI. So that's our test coverage. Now, I didn't put any arrows here. We need to communicate that. Well, the core needs to have no other dependencies than just .NET Standard and whatever most stable libraries. You're only as stable as your most stable library. So I'm going to make sure that the UI references core. I'm going to make sure that data access references core, unit test references core. All incoming references. I like that. No outgoing references for core. Acceptance tests. Let me just finish these. And I finished all of them. All right, so that's our dependency diagram. Now, what about our core object model or domain model? I love domain-driven design, the pattern, the language that it gives us. So let's just put work order right here in the middle. And this is going to be a class diagram or just an object diagram. So I have a work order. A work order does need a status, I think, draft. So, we need a status object. And whether it's an enum or an enumerated class, Maybe we call it work order status. I'll abbreviate it here. And we have things like draft, maybe another one submitted, maybe another one assigned to a technician. And maybe then it's in progress, and maybe it's completed, and or maybe canceled. You can cancel a work order. And so we have a status, okay, has relationship. And also we need a submitter, somebody who's going to submit the work order. And so if I have an organization, let's just say, well, there's another entity, an employee is a submitter. And then we need let's see, and then we need someone to assign the work order to. So an assignee, and you can assign it to a technician. Okay, there we go. But you know what? A technician is also an employee. So let's say there's an inheritance relationship, open triangle, and maybe later on down the road, with approvers and whatnot, we may have a manager. Well, a manager kind of is an employee. A technician has a manager, so we can do that. A technician is, open there, is a, I think we'll leave it for that. A manager is an employee, a technician is an employee, and a technician has a manager. All right, so there's our object diagram. So taking that object diagram into consideration, next let's try to figure out how we're going to put this application together. Let's do a sequence diagram for just creating a new work order. When we create it, it's going to be in draft status. So if I'm starting out with a sequence diagram to explain this, then I have got my actor, and I'm just going to blow through. If you've never heard of whatever diagrams, just follow along. I'm not going to go into UI patterns. I'm just going to be abstract and say, okay, UI. In the UI, a person is going to use the UI, and they're going to go to a screen, and they're going to draft a work order. All right, so what happens? Well, in the most simplest sense, if we're not really using any kind of scalable patterns, we might say that the UI uses the work order object directly, and the controller or the screen code or whatever component is just going to call the constructor of the work order directly. And then, a common pattern, if I have a work order repository class, maybe the UI then goes directly and says, hey, go ahead and save this work order. And of course, then we have SQL Server, and the work order repository is just doing an insert statement. Okay, that could be a possibility, but that doesn't scale at all, because now we have to do all that for manager, technician, employee. It puts too much logic. It basically guarantees all of your logic except for your SQL statements are going to be right there in the user interface. So we don't like that. We want to do something. a little bit better. So let's talk about drafting. Let's consider an alternative and come up with a pattern. And let's use a little bit from CQRS. Let's draft some commands, and let's use a bus pattern. So let's try this again. How would we describe if we were going to do another pattern? Well, let's ignore the user interface for a little bit longer, but the actor is still going to draft the work order. Okay. And then instead of going directly to creating our aggregate root in our domain model, which would be work order, one of our entities that serves as a root of an aggregate, let's instead craft a command where we pull away the user's intent. The intent of the user, or the request of the user, is to draft a work order. So let's say draft work order command. And I'm abbreviating, but in C# you wouldn't abbreviate. All these become types. So we would definitely create this command similar to a DTO, and then we would pass it to a bus or an iBus, which is an abstract. So we'd say bus.send. And then this would, look around and look for a request handler. And if we're going to specify this type of pattern, then it's going to look for the right handler and say, hey, will you handle this command? Okay, great. We need to do that. Well, how do we do that? Well, we need a lot of classes that inherit from here. Well, this would be a draft work order command. And yes, all of your diagrams like this can be completely flexible. You can mix and match paradigms. The open triangle is inherits from. And so through inversion of control and abstract, we're going to extend this, and actually it's going to implement the handle method. Okay, you can mix and match all of these diagrams, all of these things. And so we have a handle method. Well, how does it do it? Well, we're going to have a work order object, and this is the class that actually calls the constructor of the work order and sets status to draft. And now we need to save it. Let's say an OR mapper. Well, let's see how this continues on. So we have a draft work order command over here. Oh, did I say command? I meant handler. Yeah, some of you are confused. We have a handler class that handles the command. Now, in this handler, we can turn right back around and we can actually create some type of command to send back to the bus. So if I was to say save, entity or save aggregate command, and then I actually created that command, I passed in the work order to this save aggregate command, and of course I get the object back, and then I pass this back and say bus.send, passing this save aggregate command. Well, now I am asking hey, here's another command that you need to handle and you need to route. And so then what happens? Well, we go right back to our abstraction. We say, hey, I need to save an object. And of course, in this case, a work order would probably, if you have I entity or some type of interface, you'd kind of do an inheritance relationship there. But let's just say we have a save aggregate handler that, oh, by the way, inherits from I request handler. And so in this case, this is how that relationship would work. It would implement the handle method. And then if I'm just going to extend this over here for drawing's sake, then we would have SQL Server, and then we would have an insert statement. Okay, so that's how we can use our sequence diagram to describe, hey, what we're doing, a pretty sophisticated application pattern where after you design this, every one of these would then be on the docket for a development task. Hey, we need the draft work order command. We need the iBus. We need the iRequest handler. We need a draft work order handler. We need iEntity work order class, save aggregate command, a save aggregate handler, and those would all be code files that we need to create. Now, a work order is something that has a process, that has a flow, and so we can use a state machine. And so if I have a work order right here, the first status that we have is draft. Okay. The next status we have is submitted. All right. And these are all facts. So these are all past tense as a status. Okay. It's not a verb because it's something that is submitted or is draft. And then another status would be it is assigned. And then maybe the next status is it's in progress. Okay. And the next status is complete. I'm going to ignore canceled for now, but you can see that we have transitions, kind of a synchronous workflow that this work order has. Now, all of these arrows, you name them with a verb. So if we are going to go from a draft to submitted, then we are going to submit the work order. To go with this transition, we are going to assign. See that verb? And if we're going to go to assign it in progress, we're going to begin. If we're going to go to in progress to complete, we are going to complete it, which is the same verb. Okay. Now, let's say I've assigned it, but now I say, no, I want to bring it back. I want to bring it back to this status. Now we can go backwards and we can say maybe not unsubmit, but unassign. And if I go backwards, I can unsubmit, submit. And if it's in progress and oh, wait a minute, well, maybe I can shelve it, whatever word you want to bring up. And if it's completed and I go in progress, maybe I call it, hey, maybe I'm going to reopen the work order. Now, what do we have here? We have a lot of lines, we have a lot of bubbles. How do we translate this into actual code? Well, we already have our work order. It's an entity. We've declared it to be the root of an aggregate in domain-driven design speak. And draft is a status, okay? Whether we use an enumeration or whether we use an enumerated class, draft essentially is an instance of status. Same with all these. And then every one of these lines is a command. So let's just make up an abstraction. We need an abstraction to talk about and reason about. So let's just make one up. I state transition. Or yeah, I state transition. That's great. And so if we have an I state transition, that means that every one of these lines could represent an implementation of I state transition. All right. So what would we really need this abstraction to be defined as? Well, we absolutely need to know if this is valid. Okay. And if we need the work order to see if it's valid. And then how about is allowed? Is allowed, and maybe the work order and whatever employee is trying to do it. And that way we can create an implementation. We can say submitted state transition. Well, hey, is this one valid? Well, it is if the status of the work order is draft, but it's not valid if the status is something else. Well, is it allowed? Well, let's make up a business rule here. If we are in progress and if we're in progress, is the assign state transition allowed? Well, it's not valid, but allowed might only look at who it is. So if the work order is assigned to the employee that is passed in, well, maybe it's allowed because they can do something next. But if it's not assigned to them, maybe is allowed. No, you can't transition. You can't do anything with a work order that you're not assigned to. So this is how we make these types of pattern decisions. And this is a state diagram. And then let's just count how many of these implementation classes we're going to create. 1, 2, 3, 4, 5, 6, 7, 8. We need 8 implementations of this class. And so as we draw these diagrams, it then becomes really obvious what tasks to perform and how to fill up our development task board, how to break up a feature that's come on our Kanban board and actually decompose it to the different development work that we need to perform. And so use a whiteboard, use paper, don't immediately go to Visio, don't even immediately go to Plant UML, just use your pen or pencil and draw some of these application architecture diagrams, because in order to get clarity with everybody, you need to have a picture, because if you're just using your words, everybody is trying to get the same picture in their head of what you intend to do and how to do it. Everybody needs to build that picture for themselves. And if you let everyone do it just from words, everyone's going to have a slightly different picture. So if you can distill your understanding and your decisions into a picture, now you've given them the picture instead of forcing them to come up with their own, which is invariably going to be a little bit different than the picture in your head. So I hope that helps. Again, if you have an architecture question, just tweet at me at Jeffrey Palermo, and I'll be happy to answer your question. And as always, if you need any architecture help, ClearMeasure, we are a software architecture company. We exist to help you move fast, you deliver quality, you run with confidence, you can do more internally so that you and your team is performing at another level, and you're more capable and you're delivering for your customers and delivering for your company, which is fantastic. So thank you so much. And until next time.